Tonight we're going to look at exponential regression and how to enter that into the calculator. The example we have came from, I had to scan it in, so that's why it looks a little different, but it should work. The table below shows the results of an experiment involving the growth of bacteria. So that's what we're going to look at, time versus number of bacteria. So if you're asked to do an exponential regression, then it usually is stated somewhere in the problem. So on A down here it says write an exponential regression equation. So sometimes it might say linear, or it might say power, usually, or logarithmic. Sometimes, most often though, it is exponential or linear. Those are the two main ones. So you should be kind of looking for that. So to do this, we are going to go to our calculator and put these values in our calculator. So get your calculators. I'm going to see if I can move that a little bit. Hold on a second. Alright, now I still have I can still see the table. Okay, so what we're going to do is click on the Stat button and edit. And in there we might have some things from another experiment, maybe the Survivor Lab. So we need to go to the top of L1 with the cursor and hit clear. And then when you arrow down it should clear. Do not hit delete. Clear and go down and it clears. If you hit delete, you may have to go back to Stat and choice 5, the setup editor, and then when you go back to Stat and edit, it should reappear. L2 would reappear if for some reason you deleted it, or L1. Now to enter these, just type in what you see here. So 0, 1, enter, 3, 4, 5, 7. And then arrow over to L2 and the same thing. When you're done, double check that you've entered in the numbers correctly. If you've made a mistake here, then it could mess up the entire thing. Alright, now if they want us to figure out an exponential regression equation, we should make sure that some of you may or may not have the diagnostics on. Let's go through that. So we're going to go to second 0, which is the catalog. And when you get to the catalog, it's obviously in alphabetical order. We want diagnostics on. What that does is gives us an R value. We're not going to use it, but I just want us to have, the same thing. So I'm going to go, I need to get to the D's. To get to the D's, it's already in alpha mode. You can see the upper right-hand corner as a capital A of the calculator. So I'm going to just click on the X to the -1 button, which is the green D. And that brings me down to D's, and then I'm just going to arrow down to diagnostics on. You only have to turn this on once. You don't have to turn it on every time. Just once, and you're good. Okay? It's not going to take up memory space. You don't have to worry about it being on. So it's done. Now, to get the exponential regression equation, I go to Stat, Calc, and I go down and find EXPReg, which I think might be 0. EXPReg, which is 0. And then if you have an old calculator like this one is, then you have to get L1, L2, which is second 1, commas above the 7, and then second 2, L2. Alright, if you have a new operating system, Your calculator is a newer one than this one. Then when you go to Stat Calc and type in 0, yours says X list and Y list. So in X list you want L1 and in Y list you want L2. You want to clear the frequency list and you don't need the store reg EQ to have anything in it either. And you would just arrow down and then hit enter when it's flashing on calculate. For us on my old one, I'm just going to hit enter here. And so this is what you will see. Now this is not what you would write, but this is what you would see, and hopefully yours is the same as mine. This is not the first time I've done this, so it is what I got the first time I did it, so I'm 100% sure mine is correct. If yours is not, go back and check, just pause the video and go back and check that you've entered in the right numbers in your table. All right. And if for some reason you don't have the diagnostics on, it's okay if you do not have the R squared or R. We're not going to use them this time. All right, so now I'm going to go back and write some stuff down. So first of all, to get the diagnostics on, I did second 0, which is the catalog, and then I typed D, or I typed x to the -1 so that I could access D, and then I did diagnostics on. And I think I hit enter a couple times. Then to enter the information, I went to Stat, Edit, and I put L1 and L2. For time is L1 and number of bacteria is L2. And then I did Stat Calc. So if you have the old operating system, so on the older calculator, it looked like this. It just came up Stat Calc. Oh, and we were looking for 0 EXP reg. So then on the older calculators it comes up EXP reg, something like that, and then you have to type in L1, comma, L2. On the newer calculators, it comes up X list, Y list. And you want L1 and L2. And then you do not want anything in the frequency list or in the store. You want those to just be empty, and then at the bottom of that it should say calculate. And so you want it to be flashing on calculate with X list and Y list, and then you'd hit calculate and it pops up with the same exact equation. So the equation we got was, y equals a asterisk b caret x. You don't want to write that as your answer per se. We also got it to say a is 2.0958 and b is equal to 6.0399, and then it said r squared was equal to 0.9999 and r was equal to 0.99997, something like that. To write the exponential regression equation, you want to write y equals 2, and it says rounding values to the nearest hundredths place. So it's 2.10, because 2.095, the 5 is going to round up the 9 to 10, which rounds this 0 up to a 1. So it's not 2.10, and then b is 6.04 to the x. So you would need to have this calculator work, Stat Edit, Stat Calc, EXP Reg, and this equation written out. The other stuff you do not have to have written. I just did that so that you have it in your notes if you need to refer back. So then for part B it says, based on the equation, how many bacteria were present after 6 hours? So you need to realize that the hours was your x, okay, and the number of bacteria is your y. So how many bacteria were present after 6 hours means they're giving you x is 6 and they want to know what the y is, how many bacteria. So if they're giving you the x and they say based on the equation, then you just substitute it into the equation. So it would be y equals 2.10 times 6.04 to the 6th. And then you use your calculator to calculate that. So back here, I would go to the home screen and I would do 2.10 times 6.04 to the 6th. And if you're doing it differently, remember you cannot multiply the 2.10 and the 6.04. You'd have to do the exponent 6 first to the 6.04, then take that answer times 2.10. So you'd have to do 6.04 to the 6th first, PEMDAS, times 2.10. And you get the same answer. Okay, so y is equal to 10196,260. Going back there for a quick second. To the nearest hundredth, it'd be 61. 10196,260 point. Now wait, what happened here? Hold on. 10196.2.6 10196.2.61. Okay. So that would be 101,962.61 bacteria present. All right, so hold on a second. Yep, I just double checked on my calculator. Then for part C, based on the equation, how many bacteria would be present at 10 hours? So same thing, y equals 2.10 times 6.04 to the 10th. So 2.10 times 6.04 to the 10th. And so we get this big number here. What is that? 135,702,760.1. So y is equal to 135,702,760.1. All right. And then for D, based on the equation, during what hour does the population reach 100 bacteria? To the nearest tenth of an hour. Okay, so this one is saying, what's the x? X is equal to what? The y is equal to 100 bacteria. So if I look at my table, 100 bacteria would be somewhere between 1 and 3. So I'm thinking number of bacteria is 100. There's a couple things I can do. So I can go back to my calculator, and I need it to be to the nearest tenth of an hour. I need it to be, 100 equals that. So what I could do here is I could take and I could make I could guess a little bit here. I could try plugging in 2.10 times 6.04 to the, let's try to the 2.5. Okay, so that's 188. So I need that to be smaller. So 2.10 times 6.04 to the, let's try 2.25. Okay, 2.10 times 6.04. And this is going to take a while. This is not the way I would normally do it. I'm just kind of showing you what you could possibly do. So I guess I could go 2 raised to the 2.15. Let's see what that does. Okay, there we are, almost 100.33. So, what if they had said take this out to the nearest hundredth? My answer should be, close to 2.2 here, looks like. Another way to do this would be to actually go to your calculator and graph this. So you can go into y equals, and you could put in 2.10, and then 6.04 in parentheses, raised to the x. And then you could put in y2 equals 100. So I think that the answer is going to be around 2.2, somewhere around there. Now, if you go and just graph this, you're never going to see y2 equals 100. So you could take your window value. Oh, my y max is already at 500 from the previous lesson. So let's lower this down to, say, 150. Okay. And we might need to change that x max, but let's just try it. All right, so there it is, and that I need the intersection of that. So my window was fine. So now go to second trace, choice 5, and you can just hit enter, enter, enter. And look at it, 2.148. So I said 2.2. It's actually 2.1 because the 4 keeps it down. So going back here onto our problem here, we had 100 equals 2.10 times 6.04 to the x. And so in y1, I put 2.10 times 6.04 to the x, and in y2, I put 100, and I had the x min at 0, it just happened to work, and the x max at 15, I could probably do 10, and I had the y min at negative 10, and the y max at, I put it at, I think 200 was fine, and then we did second trace intersect. So, I kind of guessed a couple of times in the beginning, but this will give you a surefire way to do it. And then we're going to actually learn algebraically how to solve this equation. 100 equals 2.10 times 6.04 to the x, algebraically using something called logarithms. That's for a later chapter. Back to second trace intersect, we got x was 2.14 to the nearest tenth of an hour. That's 2.1 hours. Okay, and that's how you can do some exponential regression.